Hello, I am Marlon Blanco, and I am doing the Truss Visited project. So for step 1, we're going to find our angle 1 and our angle 2. So there we have our adjacent and our opposite. So we're going to do inverse tangent for, we don't have our angles, so we're going to do 110 divided by 30. And for our angle 2, we're going to do 110 divided by 50. And that would equal to 74.74. And make sure you round to the nearest hundredth. And for our angle 2, we're going to get 65.56. Boom. Now we're going to find our EFX and our EFY. Alright? And our EFX and EFY are always going to equal to 0 because they cancel each other out. So we're going to do MB plus MC plus MD. And we're going to do Ray plus Ricky plus our little downwards force, which is 1250. Alright? So first I'm going to solve for my EFX. So we're going to find out if my angles are clockwise or counterclockwise. So B is going clockwise, D is going clockwise, and C is going counterclockwise. So we're going to do MB plus MD equals to MC. So we're just going to plug in our numbers there. So we're going to do 30 times 1250 plus our MD, which is 50 times 110, which is equal to our MC, which is, what is our MC? Our MC, okay. Our MC is from the pin all the way to the little rolly thingy. All right? So we're going to do Ricky, 80. All right? And when you add those up, you get an equal amount of 43,000. Equals to Ricky, 80. So we're going to have to get Ricky by itself. So we're going to divide 80 on both sides. And for that, I would get 537.5, which equals to Ricky. And to find Ray, we just subtract Ricky from the 1250. So 1250 equals to Ray plus Ricky. And we already found our Ricky, so we're going to subtract Ricky from the 1250. We're going to do 537 minus 5. And that would equal to 712.5. So that's our Ray. Alright. See that? Sorry for the camera angles. Alright. For our next step, we're going to solve for our variables for C. So I'm going to do a little C. And I'm going to do all the little forces that are going into it. So I'm going to do downwards, and I'm going to go to the left, and our upwards. So we already know our Ricky, so we're going to do 537.5. And we're going to make a triangle out of these little angles. So we're going to do this. And we're going to do 537.5 over there. And we're going to add our angle 2, because, you know, we're solving for C. So our angle 2 is 65.56. So now we're going to be doing, we're going to be doing 537 divided by sine 65.56. You know, I always like to solve for my hypotenuse first because I find it more easier that way. So we're going to do that, and we're going to get 590.40. Make sure you round to the nearest hundredth always. Alright? And next, we're going to find our little x. So we're going to do 537.5 divided by tangent 65.56. And that would equal to 244.27. And that's our x. Alright. So now we have our C variables and whatnot. Alright, draw a little line there. Now we're going to find our A variables. Alright. We're going to do a downwards force there, a rightward force, and an upward force for Ray. So So it would equal to 712.5. And we're going to do the same process we did for C. We're going to make a triangle. We're going to use our angle 1 this time because we're solving for A. So it's 74.74. 712.5. Can you see? Okay. And we're going to find our hypotenuse again because that's the only thing that matters right now. So we're going to do, oops, hold on. We're going to do 712.5 divided by sine of 74.74, which equals to 738.54. All right. Let me see that. All right. There we have it. And we don't even need to solve for our x, because we already found our x out of our c right there. So we're just going to flip that page over. Okay. Now for our last process is to draw the graph. We're going to have our A, our B, our D, and our C. Right, so for our array, we had 712.5 pounds. Make sure you put it in pounds. And our downward force is 1,250 pounds. For our Ricky, we got 537.5. All right. Then we're going to do an upwards force here and a downwards force here, you know, cancel each other out. And it's going to be the same as our downward force here because, you know, they cancel each other out and whatnot. Then we're going to do a downwards force there. All right. Boom. And what we got for our C was 590.40 pounds. All right. And the reason that these angles are opposite is because they need to cancel each other out. So, yeah. 0.54 is what we got for that. Don't forget our D, which is 50 pounds to the right. 50 pounds to the right. So that's going 50 pounds to the right. So our racks would be 50 pounds to the left. All right, boom. I'm just going to draw our other little x coordinate, whatever you want to call it here, which equals to 244.27 pounds and 244.27 pounds there. All right. And the reason that these two are equal is because they cancel each other out, you know? And so this would be tension because, you know, they're grouping together. All right. And these are pulling apart, so that would be compression. Boom. And that's tension right there. And yeah, that's what I got for my answer. Boom shakalaka.